Right, so this lesson, we are looking at the chapter 1.5 in Pure 2 about improper fractions. This will be the last chapter and lesson on partial fractions, which is also one that is sort of the most hidden that you have to recognize how to do that. Speaking of improper fractions, you do have learned in Pure 1, chapter 7 about algebraic division. So just let's brush up the definition about improper fraction. First of all, a fraction, an algebraic fraction, is improper if the degree of the numerator is at least the degree of the denominator. Now, for example, x squared minus 3 over x plus 2. Now, that is improper because x squared compared to x to the power of 1. Compared to x to the power of 1. X to the power of 1 over x to the power of 1, that's also improper. X cubed over x to the power of 1, obviously improper. Now, one thing you have to remember is if it is the same degree as well, that's also known as improper. In numeric, if you think about numerical fractions like 3 over 7, that's clearly not improper. This is not improper. Now, 9 over 7, that is improper. 10 over 7, that's improper. 11 over 9, that's improper. But if you have 11 over 11, that's improper as well, okay, in algebraic terms. But we compare the power instead of the coefficients. We compare the power, okay? So when dealing with, now this will come back in integration, so you have to remember that. Well, I'll remember you later on anyway. Right. Carry on. Okay, so when dealing with improper fractions, we can split the partial fractions by using algebraic division. Algebraic division. Okay. Right. Example below. Let me clear this space and just keep. Given that x cubed plus x squared minus 7 over x minus 3 is equivalent to this. Now, take the hint. This is improper fraction. So when you see improper fraction, you should be doing algebraic division. Okay. The other hint is if you see this format, then that's also algebraic division. That's an ugly curly. That's a better curly bracket. Okay, so that's the algebraic division. So let's do the algebraic division. Okay. X cubed plus x squared. Now you see the x term is missing. Therefore, we do have to fill in the gaps. We do plus a 0x in there. Remember, you need to have every power of x in a division. Minus 7 divided by x minus 3. Next, we compare how many x in x cubed. We need to multiply x by x squared to get x cubed. So x squared times x cubed, x squared times 3, negative 3x squared. Do a subtraction. 1x squared minus 3x squared, that's a positive 4x squared. Bring the 0x down. X times 4x gives 4x squared. So 4x times x, 4x squared. 4x minus times minus 3, negative 12x. Minus that, minus makes a plus, 12x. Bring it down, minus 7. Times it by 12, 12x minus 36. Do a subtraction. Minus 7 minus 36 is 29, positive 29. Now, you would expect remainder. You will expect remainder because there is remainder, okay? So how we write this is, if you have a different color of highlighter, this is the best time to use it. X squared plus 4x plus 12 will go into here. The remainder will go in there. Okay, so we're going to rewrite this as, so our final answer, x cubed plus x squared minus 7 over x minus 3 is equivalent to x squared plus 4x plus 12 plus the remainder over the divisor, x minus 3. And that will be the final answer. All right. Next one, let's move on. Example, given that x squared plus 5x plus 8 is equivalent to ax plus b, x minus 2 plus c, find the values of a, b, and c. Now in here, you can try to cheat without doing the algebraic division. So I'll show you both ways how to cheat. As a teacher, I shouldn't be saying this, but I'll teach you how to cheat. Yes, teaching you how to cheat. But if you want to quote me, make sure you keep it in context what I'm trying to teach you cheating here. So the proper way is to divide x minus 2 on both sides. So if you divide x minus 2 on both sides, okay, divide by x minus 2, divide by x minus 2, divide every single term by x minus 2, then you will have x squared plus 5x plus 8 over x minus 2 is equivalent to just ax plus b plus c over x minus 2. Then this will become a very similar question to the example above. Nevertheless, so what we'll have to do in here is we'll just do a little division. X times x is x squared, love it. X times 2 minus 2x, minus make it plus 7x plus 8 plus 7, 7x minus 14, minus make it plus is 22. So you've learned how to put it in that format again. That x plus 7 goes in here. That 22 goes in here. So my final answer will be x squared plus 5x plus 8 over x minus 2 is equivalent to x plus 7 plus 22 over x minus 2. Okay. Or you can cheat, okay, in here. So how do we cheat? Now, we know because they're given left-hand side equals right-hand side. What it means is we can use both sides. So if we start from right-hand side, what we can do is we can expand the bracket. Now, I'm going to rewrite the right-hand side once. Now, this question is not a show that question. What it means is you don't have to. That means you can't. It means you can't use the result. What you can do here is because it's given to you, you can use the result. So in here, the right-hand side, if I expand the bracket, so ax squared minus 2ax plus bx minus 2b plus c. Then what I can tell is if I compare coefficient, compare the terms with left-hand side, then what you see is the x squared term, they've got x squared. So compare the x squared term, you see a equals 1. If I compare the x term, the left-hand side is 5. But on the right-hand side, the x term is negative 2a plus b. We know a is 1, right? So 5 equals minus 2 plus b, b equals 7. And if we compare the c term, the constant term, left-hand side is 8. On the right-hand side, the constant term is minus 2b plus c. We know b is 7. So 8 equals minus 2 times 7, minus 14 plus c. C equals 22. Now, if you compare that with the left-hand side, with the first method and the right method, voila, both are the same. All right? So we have successfully found the value of a, b, and c. A is 1, b is 7, c is 22. Both ways equally work. Oh, but for left-hand side, you do actually, for this method, you do have to say a equals 1, b equals 7, c is 22. Right, next one. Oh, your turn. This is the last one. Yes. Okay, so this will be the last exam practice. Have a go at the question. When you do division for this one, be mindful the x squared minus 4, you do need to put in the extra x term on the outside. If you have no idea what I'm talking about, I can set you up in the beginning and you can pause the video. But if you know what you're trying to do, you can pause the video now and have a go at the question. So I'll give you, I can start you off if you need to. So in here, I can tell this is improper fraction because x to the power 4 compared to x squared. So I need division. So when I do algebraic division, I need to have every power of x visible in both inside and outside the bus stop. So minus 2x cubed, minus 5x squared. As a smart mathematician, you do realize there's no x term, minus 4. Outside, I've got x squared. There's no x term, so plus 0x minus 4. You can pause the video, have a go at the question, but if you still want to see how I do it, you can. Right, so x squared to multiply into 3x to the power 4, I need a 3x squared. So that will give me, actually, let me make this green. Right, so 3x squared times x squared is 3x to the power 4. 3x squared times 0x is just 0 x cubed. 3x squared times minus 4 is minus 12x cubed. Minus 12x squared. Do a subtraction, that's gone. Minus 2 minus 0 is minus 2x cubed. Minus 5 minus 12 is plus 7x squared. Bring the next term down. X squared, and you multiply by minus 2x. Minus 2x times x, minus 2x cubed. Minus 2x times 0x, minus x squared. minus 2x minus times minus 4, positive 8x. Do subtraction, that's gone. 7x squared, 0 minus 8 is minus 8x. Bring the last term down, minus 4. I need to multiply by 7. 7x squared minus 0x, minus 28. Do subtraction, minus 8, so minus 8x. Minus 4 minus 28 is minus plus 24. So therefore, just checking my model answer. Yes, I'm right. So therefore, my final answer would be that one goes in here. That one goes in there. You can see this time the denominator, it helps you denominate x as an x term. So you're more or less, on the right track. So that my final answer will be 3x squared minus 2x plus 7 plus minus 8x plus 24 over x squared minus 4. So my A is 3, B is minus 2, C is 7, D is minus 8, and E is 24. And that's the end of chapter 1.